Yeah. So welcome, guys. Let me enter the Google. So tonight we are going to look at a very important topic, that's electrochemistry. It's among the physical chemistry that you have to know. So electrochemistry is just the study of effect of electricity on substance. Study of effect of electricity of substance or compound and how chemical reaction produces. So in electrochemistry, we mainly need three important things. Number one is the redox and oxidation. That's a redox reaction. Reduction and oxidation. That's redox reaction. Uh, Number two, we're going to deal with electrochemistry. That's the voltaic cells. And number three, we're going to deal with electrolysis, and that's electrolytic cells. So let's start with the first step. That's the oxidation or redox reaction. So sometimes when defining reduction or oxidation, it can be defined in different ways. It can be defined in different ways. Way number one, reduction can be defined in loss of oxygen. So reduction is just a loss of oxygen. But when we are in electrochemistry, reduction is gain of electrons. Also, it can be defined as addition of hydrogen. It can also be defined as decrease in oxidation number. So all these are acceptable definition of reduction. Then oxidation we can define oxidation in these four ways. Number one is addition of oxygen. Number two is loss of electrons. Number three is a loss of hydrogen, and then number four is increase or in oxidation and number. Meaning that I do advise students that wherever you see that these things they are opposite or they are contradicting, always stick with one. Shika tu moja. The other one will automatically be the opposite of the other. For example, unaweza amua tu ushike tu reduction. Unaweza amua ushike tu reduction peke yake. So in exam situation, unaandika tu ile reduction ambayo ulikuwa unakumbuka, and then the oxidation will be automatically opposite. So that point, most important thing that you are going to look is the how do we calculate the oxidation number. When we are calculating oxidation number, we follow these rules or these steps. Number one, oxidation number of combined oxygen is always -2, except the peroxide of sodium peroxide and hydrogen peroxide, where oxidation number is -1. So anywhere that you see oxygen, always the oxidation number is -2, except the sodium peroxide and hydrogen peroxide. Hence, the oxidation number is -1. Number two is oxidation number of combined hydrogen is always +1, except the hydride of sodium hydride and potassium hydride, where its oxidation number is -1. So ukiona tu hydrogen mara yote, always the oxidation number is +1 except the hydride. Number 3, all atoms and molecules of element have oxidation number of 0. Any atom and molecules unasema tu is equal to 0. So ukiwaambia utafute the oxidation number of sodium unasema nini? Then whatever the sodium is equal to the 0 is equal to 0. So you equate to 0. Sodium, all combined atoms and molecules. Step number 4 is all combined metals and non-metals have oxidation number equal to the oxidation number, oxidation state or valency. So mostly these things applies to radicals. Radicals where we have, for example, ammonia. It is radical 1. So meaning that has a negative. It has a negative sign, meaning that the valency is -1. For example, carbonate is valency 2. So badala useme is equals to 0, you will say is equals to 2. Let's start with our one question. Number 1, swali lilikuwa inatuuliza hapo, calculate the number of oxidation number in the element in the bracket. So hapa wametupatia NO, that's the nitrogen oxide, NO. So anataka nini? Oxidation of N peke yake na wanataka. So you will say that N plus any place that you see oxygen, kwa tumesema ni, tunarudi hapo sasa, tulisema ni -2. Tumesema ni -2. So tunasema into bracket -2 is equals to 0. Tulisema molecule zote ni 0. So itakuwa saa nini? Itakuwa plus minus, itakuwa minus. So itakuwa n minus 2 is equals to 0. So hii 0 inaenda inside, so n is equals to +2, and then that's how you show it. An oxidation number you show by you give the sign in front of the number. So sign usually comes before the number. So example, look at this, nitrogen 4 oxide ikawa negative juu. So bila useme 0 utasema aje? You will say negative is equals to -1. Then you calculate it. Look at this phosphorus. Utasema aje? Utasema PO4 is equals to -3. Then ilikuanga -2 times 4. Then you calculate like that. So that's how you calculate oxidation number of certain substance. So the first part is over. The second part is electrode potential. Electrode potential is formed when a metal is placed in its solution of its ion, meaning that zinc electrode potential is formed when zinc is placed in zinc ion or copper is placed in copper ion. So meaning that in electrode potential is usually formed when a metal is placed in a solution of its ion. So for example, when a zinc rod slipped into a zinc sulfate solution, the zinc metal dissolves in solution, and at the same time the metal ion are deposited in the solution while electrons remain behind the electrode. The metal rod becomes positive with respect to the solution. The reaction occurs at the same time, and depending on which one is faster, the metal becomes charged with respect to its solution. And potential differences usually exist between the metals and its solution. This potential difference is known as electrode potential. So hapa sitaki kuingilia sana. I want to go direct to the electrochemical or voltaic cell, which is very common in exam situation. In electrochemical cell, we have this combo. Number 1, we have 2 half cells that contain 2 different electrolytes. Number 2, we have the salt bridge. And then we have the wires, and then we have the voltmeters. So an electrochemical cell is formed by combining 2 half cells. So if you want to form a certain electrochemical cell, it is usually formed by combining 2 half cells. The 2 half cells are connected using something known as salt bridge. When 2 half cells are connected, the more reactive metal get oxidized. Please note this. the more reactive metal get oxidized, meaning that it loses electron, and the less reactive metal ion gain electron. It gain electron to form a corresponding metal. So it gain electron to form metal. For example, electrochemical cell between zinc ion and copper ion. So in reactivity series, zinc na copper gani inakuja mbele? Ni zinc ndio inakuja mbele. So if zinc inakuja mbele, meaning that the zinc is the most reactive metal, and the most reactive, what will happen to it? It loses the electron. It loses the electron, or it get oxidized, and the less reactive metal gain electron. So this is how it is. Sometimes unaweza waambia uchore kwa exam station, sometimes unaweza pewa hivi. So ukipewa swali kama hii, number 1, ile kitu utaulizwa ni distinct. Hii lazima uulizwe. Substance X, this is salt bridge. This is the salt bridge. Number 2 is the current flow. The current flow. Current always flow from the one that is highest reactive metals. Always in a flow from higher reactive metal. So in a flow from zinc and copper. In the case of zinc and copper, zinc is the has high interactivity. It's high interactivity series. So in a flow from zinc. So that's the one thing that you have to know. The second thing that you have to know. Number 3, ile kitu ngine unafaa ujue ni oxidation of half reaction. Half reaction, what is going to happen? So zinc, it is a high reactivity series. What will happen? Tulisema if metal is high reactivity series, more reactive metal get oxidized. So hii inakuwa nini? Oxidized, meaning that it loses electron, because oxidation and the loss of electron are usually opposite. They are usually opposite. So gain of oxygen is a loss of electron. Gain of oxygen is a loss of electron. What will going to happen is we have the zinc solid. So it will lose the electron. It will lose these 2 electrons. And the copper will gain these 2 electrons. Copper will gain these 2 electrons. That's a copper ion plus 2 electrons to form copper solid. So these are reduction na ina form nini? Corresponding metals. And this is the oxidation. Oxidation meaning that it is loss of electron. Oxidation is a loss of electron. So it will lose this electron, and this electron that has this electron, it will be taken by copper. The copper will gain that 2 electrons to form copper solid. So that's the oxidation half reaction. So there's the oxidation half reaction and there's a reduction half reaction. The other question that might appear is overall reaction. In overall reaction, ile kitu unafaa ujue ni reaction wakati inaanza inafaa ianze na solid, na wakati inaisha inafaa iishe na solid. Jua hivyo kwanza. Reaction wakati unaandika inafaa ianze solid, iishie solid. So look at this. So we have the zinc plus copper ion. So inaanza na zinc solid, inaishia na copper solid. So we have the zinc solid plus copper ion, that's aqueous. It will give us zinc ion plus copper solid. It will give us zinc ion plus copper solid. So that's how it's written in salt bridge. I think this is the observation. Generally observation play will reduce. What will happen to it? Decrease in mass in reduce, because kwa sababu gani? Already it lost electron. So what will happen to its mass itakuwa decrease. Hii mass yake inakuwa increase. So then there's a deflection in voltmeter. Kwa sababu gani? Because there's a electric current. Another question is the purpose of salt bridge. The purpose of salt bridge, number 1 is to complete the circuit. Number 2 is to maintain the balance of charge on both of half cells. So it has to maintain the balance. And I think unaweza ambia uandike nini? Uandike the cell representation or cell convention. Unaweza ambia uandike cell representation or cell convention. So ukiambia uandike cell representation or cell convention, unaandika to directly like this. You just write like this. So you write with, when I start with zinc, then phase boundary, then copper ion. So copper ion, then you have not copper ion, zinc ion, I mean, because tunafaa tumalize hii side. Sorry, unfortunately this side. We have the zinc, then zinc ion. So the side that ilikuwa na high reactivity in series umemaliza, then unaleta hizi line mbili ambazo zinaitwa salt bridge. They represent salt bridge, the double lines. Then you write the copper ions, and then we write copper. Sorry kama nimeandika vibaya, we write copper. So that's how you write it. Rudia hapa because najua hapa ndio maswali mingi zinatoka. Number 1, wakati tunaandika hii kitu ama wakati ukiwaambia uchore, always the method that has high reactivity series inachorwa the left side. So hii inakuwa the left side and this will be on the right side. Number 2, tunatumia salt bridge. Salt bridge kazi yake ni kuconnect. Number 3, you have to show the voltmeter. After that, unaweza ulizwa uandike the half reaction of the oxidation side and reduction side. Oxidation gani inaenda oxidation? The metal that is high in reactivity series zinaenda nini? Oxidation. Na oxidation inamaanisha nini in electrochemistry? Oxidation inamaanisha loss of electron. So this is the high one, that's the zinc. So zinc, it will lose the electron. And then the 2 electron that has been lost inapeleka wapi? The copper ion will gain to form copper solid. That's half reactions. Then next time unaweza waambia uandike nini? Overall reaction. In overall reaction, make sure that the side ya kwanza, ile mahali unaanza uko na solid, ile mahali inaishia pia uko na solid. So ile unaanza ni ile ya oxidation. Ile oxidation inamaanisha nini? Ni ile ambayo iko na high in reactivity series. The one that is high in reactivity series. Then ile inaishia, the solid inaishia ni the ile ambayo iko low in reactivity series. So that's how unaandika. So the in between itakuwa nini? The ions. In between itakuwa the ions. The next thing ambayo utawaambia unaweza ulizwa ni the purpose of salt bridge. Number 1 is to complete the circuit. Number 2 is to maintain the balance of charges. Number 3 ingine unaweza ulizwa ni uandike the cell convention or cell representation. Always ni vile umeandika tu kwa equation unaandika tu hapa. It's only that wakati tunaandika cell convention unamaliza tu side moja kwanza. Unaanza hii side, then unamaliza hii side first of all. So unaanza na zinc solid, then followed by zinc ion, then followed by copper ion, then followed by copper solid. Then ama unaweza tumia hii formula ambayo inaitwa anti-clockwise. Is it anti-clockwise or clockwise? Clockwise. So because unaanza na zinc wakati unaandika cell convention. Unaanza na hapa. Let me choose here. So unaanza na hapa, that's unaandika zinc. That's a zinc unaanza na zinc, then uandike the zinc ion, then uende hivi mpaka uandike the copper ion, then uandike the copper solid. So lakini always anza na the one that is high in reactivity series, then after that unaenda this ion, then the salt bridge. So these 2 lines usually represent salt bridge. Sometimes in exam situation, especially paper 1, unaulizwa what does the 2 line represent? 2 lines represent the salt bridge, and the 1 single line represent the phase boundary. So that's how we draw it. So the single line represents the boundary phase where the potential difference develops, and salt bridge is shown using the vertical broken lines or a pair of slanted. So sometimes ukiona broken line the salt bridge, usiastuki, a pair of slanted double lines. So another very important part is standard electrode potential. How do we calculate these things? How do we calculate it? That's the question that we have to ask ourselves. So the standard electrode potential is defined as potential differences for a cell comprising of a particular element in contact with one molar solution of its ion, and the standard hydrogen electrode is denoted in Anode. Meaning that in standard electrode potential, okay, when we are calculating, we follow some specific rules. Then this is here. This is all you need to know. Number one, the strongest reducing agent or weakest oxidizing agent is the species with the highest negative electrode potential. Nimekuambia saizi utachorewa table kama hii, then uulizwe what is the strongest, name the strongest reducing agent. So strongest reducing agent is the same as the weakest oxidizing agent. These are species with the highest negative electrode. So unakuja hapa unaangalia zile ambaye iko na highest electrode, highest negative. In our case ni potassium, negative 2.9, negative 2.92, or the least positive, ile iko na kama zote ziko positive, ile positive ambayo iko kidogo ndo unachagua. Number 2 is hydrogen is the reference electrode. Achana, hiyo ni 0.00 because it has an electrode potential of 0 volt. Another thing that you have to know is the strongest oxidizing agent. Hapo hizi ndio iko muhimu. Point number 1. Then point number 2. I hope you are writing somewhere. The strongest oxidizing agent stroke weakest reducing agent has the highest positive electrode potential or the lowest negative. In the above cases, it's F, not F negative. So you always pick the species on the left. So strongest oxidizing agent inamaanisha nini? Una take the one with the highest positive. So unafika hapa unasema the one that with highest positive. Ni gani? Ni hii ndio iko the highest positive. Lakini badala uandike F negative, unachukua the one on the left side. Unachukua the left side. I hope I'm clear. You think on the left side. Make sure that if you have any question, you note somewhere so that at the end of the class tunajibu. That's the second most important point that you have to know. The third important point is you're told to select two half cell that will give you the largest EMF or the best cell. You select the cell with the highest negative electrode. You select the one that with the highest negative electrode and the one with the highest positive. So you take the highest positive and highest negative. So ukisikia tu best cell ama largest EMF, you just take the highest negative and highest positive, and that's all. Number 4, if you told to draw an electrochemical cell formed between two half cells, the more negative will be oxidized. So the more negative itakuwa oxidized, hence will be drawn on the left. Hiyo tumepitia because any element that or the element that will be oxidized itakuwa inachora wapi? On the left. So in the electrochemical cell, the highest negative or the more negative will be oxidized. Kitu ukifikia tu imekuwa oxidized, it will be drawn on the left hand side, while more positive or the least negative will be placed on the right hand side on the diagram. So and I think that's another most important point that you have to know. Another important point is the overall redox reaction. The overall redox reaction is possible or visible if it has the positive value. Hiyo zitafika hizi mbili zitafikia. Unaweza ambiwa upewe a certain equation then ufanye the electrode potential. Unaweza ambiwa ufanye nini? The electrode potential. Ukipata the electrode potential is positive, the reaction is visible or the reaction is possible. Ukipata negative, the reaction is not possible or the reaction is not visible. I hope that place I'm clear. A solution of less reactive element cannot be stored in a container made of more reactive element, as the more reactive element will displace the less reactive element. Sometimes unaweza waambia kwa swali, mbona metal X cannot be stored in metal Y? Kwa sababu gani? Utasema because metal Y is more reactive than metal X. Hence, it will displace the less reactive metal X. Another thing that you have to know is when you're told to select two elements that will give you the least workable EMF, you have to arrange in ascending order. So that's what you know. That's what you're supposed to know. And these 4 important points are very crucial, very important indeed. Number 1, the strongest reducing agent ukisikia unachukua gani? Unachukua the highest negative. And then unachukua the right one, not left. Ukisikia the strongest oxidizing agent unachukua gani? The highest positive. Now you take the left, not the right. Then ukiambiwa select the 2 half cell that will give you the largest EMF, you will take the highest positive and the highest negative. Number 3. Number 4, ukiambiwa uchore electrochemical cell, the highest negative or the more negative will be oxidized, hence will be drawn on the left. Just know that shika tu hiyo moja, the more negative inachorwa on the left, hiyo ingine itakuwa automatically on the right. So tunaweza fanya one quick example. Hii ni overall reaction. Yeah, I think tunaweza fanya hii swali. Which one of the element is the weakest oxidizing agent? Give a reason. Weakest oxidizing agent tulisema aje? Turudi hapa. Tulisema strongest reducing agent ndo tunasema weakest oxidizing agent. So we take the highest negative. So let's take the highest negative. We take the highest negative. Then tukichukua the highest negative tulisema aje? Tutachukua the left side or tunachukua the right side. Tunachukua the right side. On the right side. And the element will be sodium. Reason it has the highest negative electrode potential. That's a 1 mark. Then, which of the element is the strongest oxidizing agent? The strongest oxidizing agent tulisema aje? The weakest, the strongest oxidizing agent tunachukua the most positive. Turudi hapa. The strongest oxidizing agent is the weakest reducing agent. We take the highest positive, but we take on the left. We pick the element in the left. So the highest positive gani ziko na positive mingi hapa? Ni plus 2.87 ndio iko highest. Then we take the element on the left. Gani iko left? Ni fluorine. Then another thing is draw an electrochemical cell formed when a silver and magnesium cell is combined. So tuko na magnesium and tuko na silver argentum. So wakati tuko kwa reactivity series, magnesium is high in reactivity series than argentum. So tulisema ile iko high in reactivity series, it will be drawn on the left. Because hii itaenda oxidized. Then the other one will be on the left. Lazima tuonyeshe the salt bridge. So write redox oxidation of the cell above. So unaanza na magnesium plus argentum ion. Hii ingefanya anze na hapa. Magnesium plus argentum ion. Then magnesium ion, argentum solid. Then tunapewa nini? Tuko na the cell calculation. Then calculate the EMF of the cell above. We have to calculate the EMF of the cell above. So magnesium na argentum. So tukuja hapa, magnesium ni negative 2.37. Magnesium ni negative 2.37, and then argentum is positive 0.8, and then we subtract it. Tunachukua 0.80 minus, nimekwambia we subtract minus, then hii ilikuwa na negative minus 2.37, and then we get 3.17 volt. Haye, swali imetuliza, if iron was used as a reference electrode, calculate the E value of aluminum and lead. So Saizi ile kitu tunatumia reference electrode tulisema ni hydrogen. Kwa sababu gani? Because iko na 0.00 volt. So tunakuja kwa iron. Tunasema iron electrode potential yake ni ngapi? Ferrum. Do you have ferrum? Yes. 0.44. We have the 0.44. Then with reference to that voltage of hydrogen, tunatafuta saa gani? Tunatafuta iron voltage yake ni ngapi? For example, tunasema if hydrogen iko na 0.00, iron itakuwa na ngapi with reference to this hydrogen? And then we find the value of x. So tukitafuta the value of x, hii iron tukipitisha negative 0.44 tukipitisha hii side tutapata ngapi? Tutapata 0.44. So lead itakuwa, aluminum itakuwa aje sasa? Aluminum itakuwa, because in any time that we calculate the EMF or the electrode potential or E value of a certain element, tulikuwa tunachukua the element then we added 0.00. So hakuna changes. For example, tuchukua for example ya silver tuseme ni 0.8, sio? So tulikuwa tunafanyanga 0.8 plus 0.00 because this is a reference 0.00, then tunapata 0.8. hakuna any changes. Lakini saizi tutumia iron as a reference, that's a 0.44. So we take the whatever the value of the aluminum, which is negative 1.66, and then we add the reference, which is 0.44, and then we got it. And then we do the lead likewise. So that's how it's tested. So that is electrode potential. Then another point that you have to know is another part that is very important. Is this diagram, like line cell easy quanky sana that. So this is the electrolysis of aqueous solution. Hapa ndo nataka sasa ni this is very important. Nakufunza in a very easy way. Number one, anytime in an exam watakuuliza tu kitu mbili. Number one, watakuuliza nini? The reaction at cathode, reaction at anode. Just know that. Watakuuliza nini? Reaction at cathode, reaction at anode. Reaction at cathode and reaction at anode. Watakuuliza tu hizo mbili. Then cathode, kwa cathode tutakuwa tu tuna produce it is produced only two substances, that is a copper and hydrogen. Kwa cathode we can only produce either copper or hydrogen. Only copper or hydrogen. So copper inaproduciwa wakati gani? Copper is only produced when using copper sulfate. So when using copper sulfate, ukiona copper sulfate au ukiona magnesium sulfate, itakuwa nini? Magnesium ama copper, whatever that imetumika at that time. Copper sulfate, magnesium sulfate, hizi zote. So copper itakuwa inaproduciwa wakati copper sulfate imetumika. Any remaining substances or any remaining aqueous solution, hydrogen gas will be produced as cathode. For example, this is the equation of hydrogen gas. This is the hydrogen ion plus 2 electron, then we get hydrogen gas. So this is for cathode. Cathode imeisha hivyo. Then tunakuja sasa kwa anode. So tunasema anode we produce only three things. Number one is the copper ion. Number two, we produce chlorine. And number three, we produce oxygen. So copper inaproduciwa wakati gani? And oxygen inaproduciwa wakati gani? And chlorine inaproduciwa wakati gani? So copper inaproduciwa when electrode ni copper. Sometimes because kwa sababu gani? Because most of the electrode inatumia nini? Inatumia inert, the like of the graphite and platinum ndo inatumia. So ukiona tu electrode zimetumika copper, automatically the anode will be copper. Ama ukiona electrode imetumia magnesium, automatically the anode will be magnesium. So metal tu ikitumia tu as an electrode, that metal will be discharged as an anode, in the anode I mean. The next is the chlorine. Chlorine is only produced when using conc sodium chloride. Conc ujue, conc sodium chloride. Sodium chloride. Conc sodium chloride. Then that's chlorine. Chlorine are produced tu only wakati ukiona tu mahali conc sodium chloride imetumika, the chlorine it is the anode. Tukuja kwa oxygen. Oxygen is the all the remaining. Oxygen is the remaining. How do we write oxygen? Oxygen we write them as 4OH. 4OH because we need to produce oxygen. Then 4OH. Then we get water from it. Get to water. Get to water plus oxygen plus 4 electron. Oxygen plus 4 electron. Oxygen plus 4 electron. So that's all. Nimekuambia nini? Ukiona tu electrolysis in aqueous solution, unaweza pata tu kitu mbili. Watakuuliza tu obvious ni kitu mbili. That's the cathode or anode. Kwa cathode tutapata kitu mbili. Copper or hydrogen. Copper tunapata wakati gani? Wakati tumetumia nini? Copper sulfate. Hydrogen tunapata nini? All the remaining. Tunakuja kwa anode. Anode, there's a possibility we get three. That's a copper ion, chlorine, and oxygen. Copper ion, chlorine, and oxygen. Copper ion wakati gani tunapata? Ni wakati copper tumetumia as electrode. Then chlorine tunapata gani? Wakati gani? Chlorine tunapata wakati tumetumia conc sodium chloride. So ukiona dilute unapata oxygen. So conc sodium chloride ni chlorine, unapata anode. Oxygen wakati gani tunapata? All the remaining part tunapata oxygen. So hebu wacha niulize swali moja sasa. Let me ask a certain question here. Let me ask questions here. Nataka sasa sulfuric acid. Nataka uniambie sulfuric acid. Sulfuric acid. Nataka uniambie sulfuric acid cathode yake and anode yake. Cathode and anode. Anode. So sulfuric acid cathode yake itakuwa aje? You can write it somewhere or you can unmute yourself and talk. Yeah, I can see that there is a message here. Abdi wanasema you can't access the chat box until the lesson ishe. You can saizi sasa ebu sorry kuna swali mingi mliweka hapa. Mwalimu enda pole. Sorry, haina shida, lakini the good thing is the video is being recorded. So unaweza rewatch another time. Hata na uweke for example 0.5 speed of 0.5. Hebu mjibu hiyo swali sasa. This question, answer hii question unangoja. Nilisema kwa cathode huwa tunapata tu kitu mbili. That is the copper wakati tumetumia copper sulfate and hydrogen for any other remaining substances. So for sulfuric acid cathode yake itakuwa aje? Cathode of sulfuric acid itakuwa hydrogen ama itakuwa copper? Hiyo swali na ngoja jibu lake. Yes. Very good. It will be hydrogen. Thank you so much. It will be hydrogen. Hydrogen gas will be discharged. So tuandika tu hydrogen vile tumeandika hapa. or just write the hydrogen, and that's all. Then tunakuja sasa kwa anode yake sasa. What about its anode? Tukisema anode tunapata kitu tatu. That is either copper. Copper tunapata wakati gani? Wakati electrode is copper. Chlorine tunapata wakati gani? Wakati tumetumia conc sodium chloride. And all the remaining tunapata aje? Tunapata oxygen. So hapa kwa sulfuric anode yake ni gani? Ni oxygen. Thank you so much. Thank you so much. So I think that's all I wanted. I think. Sorry, I will enlarge the screen. Naona kuna watu na YouTube wanaandika enlarge the screen. So that's how we write it. That's how we write it. That's all about it. So for example, look at this. Name the ion. Write the equation reaction during the electrolysis process of the process at the cathode and the anode. Electrolysis swali gani? Swali linaanza hapo. Oh, magnesium sulfate. Wametuambia magnesium sulfate. So magnesium sulfate anode yake na cathode yake ni gani? So cathode ni gani? This is hydrogen ion. Kwa sababu gani? Kuna copper mahali imetumika. Anode ni gani? Ni OH. Kwa sababu gani? Hakuna mahali imetumika aje? Magnesium electrode ama magnesium electrode ya. So the remaining itakuwa OH. So that's how you answer the question. So that's how simple it is. That's how simple it is. That's how simple it is. So another more important part that you have to know is quantitative analysis. That's the Faraday's law. That's Faraday's law. So Faraday's law, hapa ni calculation. Sa calculation, just ukishika tu formula you're good to go. Number one, formula inatafutwa mass is equals to quantity times RAM all over N times F. Quantity, that's the quantity of electricity. So quantity of electricity times RAM times N divided by N times F. So nataka nikwambie hii kitu one step by step. Hii ni quantity. This is the quantity. And the quantity natafutwa aje? Q is equals to information technology. IT. Q is equals to IT. So Q natafuta aje? I, that's the I ni ampere, the current ampere times time. And the time must be in second, please. Time must be in second. Time must be in second. Q is equals to IT. I ni, you multiply I, that's the ampere or the current times time. So ukipata Q, so that you multiply with the RAM, the RAM ambayo umepewa. The RAM ambayo umepewa. So the RAM utapewa mostly divided by N is the number of charge. For example, ukipewa zinc charge yake ni 2 times the Faraday's. Faraday's pia utapewa mostly 96,500. Mostly 96,500. So sometimes unaweza pewa gas sasa. Sometimes unaweza pewa nini? Gas. Ukipewa gas, mahali ya RAM utaandika molar gas volume. Mahali ya RAM utaandika nini? Molar gas volume. And that's all. Formula iko the same tu zote. Lakini the difference is mahali ya RAM unaandika nini? Molar gas volume. And then wakati kwa gas hatutafuti mass, tunatafuta volume ya. So mahali ya mass unaweka nini? Unaweka volume. Mahali ya RAM unaweka nini? Molar gas volume. First tufanye maswali 1 2 3. Current of 2 amperes was passed through electrolytic cell for 20 minutes. Ukisikia tu time, minute, hours, second, it must be in second. Lazima ikuwe in second. Hata usiende mbali kabla hujaweka hiyo kitu in second. Make sure that you unaweka in second. So this is time is 60. This is time 60. Then calculate the quantity of electric charge produced. So quantity tulikuwa tunatafuta aje? Q is equals to information technology. So that is I 2 amperes. That's a 2 times 20 times 60. Then unapata nini? 2400 coulomb. And that's all. Then this swali pia natafuta nini? Time taken. Time taken haina maana. Kuna swali nataka nitafuta swali kwa na mass. Yeah, tutafanya hii swali. Calculate the mass of copper deposited at the cathode when a steady current of 4 amperes is passed through a copper sulfate for 30 minutes. So tulikuwa tunajua mass is equals to that's the Q times RAM, Q times RAM over N times F, so kila kitu tumepewa saizi hapa. So tunaanza na Q. Do you have the Q? No, but you can get the Q. Q is equals to IT. Q is equals to IT, information technology. So I ni ngapi? I ni 4 times minute, time ni 30 times 60. Nimekuambia time must be in second. So tunasema time is 60. So this one will be 30 times 60. It will be 30 times 60 times 4. So it will be 30 times 60 times 4. Yeah. So it will be 7,200. So our Q will be 7,200. 7,200. So what will have what remain? RAM times RAM times RAM. So tafuta the mass of copper, sio? Mass of copper tumepewa already, RM tumepewa. That's a 63.5. 63.5. Silver, that's the charge of the copper. Copper ni valence 2, so ni 2 times Faraday tumepewa ni ngapi? Ni 96,500. 96,500. 96,500. So this is equals to mass. This is equals to mass. This is equals to mass. So tunaweka tu calculator, tunasema 7,200 times 63.5, then tunasema divide by 2, divide by 96,500. 96,500. Then we get 2.36 if I'm not wrong. Like kama niko wrong, unaweza fanya tu baadaye, lakini just this is the concept. 2.368 gram. So that's all about the topic of electrochemistry. That is all about electrochemistry. If there is an equation, let me hear. If there's any question, let me hear. Is there any question? Let me go to YouTube channel. First of all, the live. Make sure that is there any question, guys? Is there any question, please? There? Oh, so let me repeat it before I end the live. Direction gani? Your deflection of the minone. Let me go back to it and then we talk about it. Yeah, I think not here yet. Yeah, it is here. Is it here? I think it is here. Yeah. So ulikuwa unasemaje Abdi hapo kwa anode and cathode? Ulisema hapa is there a possibility that naweza weka zinc hapa? Ulisemaga hivyo? No. Haizi toka. Kwa sababu hii kitu always inatoka from ni kama tu it's not good nitumie, lakini it's just like diffusion. Inatoka from a region of high concentration to a region of low concentration. Ni kama sasa that sifai kutumia example, lakini just tu ili uelewe. Hii zinc iko high interactivity series. So inatoka from a high interactivity series to low interactivity series. So inakuwa hivyo.